In saltatory conduction, it states that the current flows through the surrounding extracellular fluid outside the myelin sheath as well as through the exoplasm inside the axon from node to node. It states that if this is a nerve, if this is a nerve fiber, and this is the axon, and there is this myelination over, and the Schwann cell is myelinated or arranged itself in this manner along this axon, then this will be called a myelinated nerve fiber or myelinated nerve cell. So in saltatory conduction, it says that the current over here will flow extracellularly, and it will end up here in this node of Renvier. And in the same manner, the current will move through the exoplasm to this. Whereas this Schwann cell is made up of, there are cell membranes over here, one cell membrane, two, three, four, and these cell membranes are made up of the lipids, and the lipids are very bad conductor of current. So here no action potential is going to take place. Whereas in the node of Renvier there is no myelination, so the action potential will occur in the nerve fiber, so in the node of Renvier. So the importance of the saltatory conduction, there are two reasons, because there are two reasons. One is the velocity of the nerve transmission is increased in myelinated fibers, and the second is the saltatory conduction. The saltatory conduction conserves energy. So one is the conservation of energy. Because of myelination, no action potential is going to take place in the 1 to 2 millimeter area. So there will be no requirement of ATP in this part at least. The same as here. So the node of Renvier is a small part where action potential is going to take place, and the sodium that comes inside as a result of the action potential, that sodium will travel in this exoplasm and will come here, and will the resting membrane potential will become less negative, and the threshold potential will be achieved, and the action potential is going to take place, and the sodium will come inside just like that, and depolarization will occur, and simultaneously repolarization will occur by the movement of potassium outside. So what happens is this is the mechanical receptors. These are the mechanical receptors over here, and these mechanical receptors are stimulated when there is a mechanical stimulation. Sodium channels come inside, and the sodium channels make the resting membrane potential less negative until a threshold potential is reached. When the threshold potential is reached, then suppose that resting membrane potential is 70 millivolts and the threshold potential is minus 50 millivolts. By the mechanical stimulation of sodium comes in, and it reaches this membrane, resting membrane potential moves to minus 50, and that is the threshold potential. And when the threshold potential occurs, is achieved, then these voltage gated sodium channels open, and when the voltage gated sodium channels open, there is an influx of sodium, and after the influx of sodium ions, simultaneously the inactivation gates of the sodium channel will close, and there will be no more sodium coming in. So when the membrane becomes depolarized, then these voltage gated potassium channels are opened, and the calcium ions are moved out. Efflux of calcium occurs, or efflux of potassium occurs, and the sodium that came inside this and caused depolarization, that sodium will move over here, and it will move through the exoplasm, and at this point it will cause the membrane potential to be less, the resting membrane potential to be less negative and will eventually cause a threshold potential, and that threshold potential will lead to the action potential over here. And in the same way, the sodium that came here, that will move through this exoplasm, it will move through this exoplasm, and the same thing will happen over here, that the sodiums were here and they are moving in the exoplasm, and at this point the resting membrane potential that was minus 70, it will become minus 70, it will become less negative because of the sodium coming in, and it will make it minus 50 millivolt. That is the threshold potential, and the same thing will occur. Action potential is going to occur over here. Simultaneously, the potassium ions are going to move outside, uh, just to complete the action potential. So this is all about the topic.